Super excited to be here with the Agentic community today. Uh, Today, I'm going to be walking you through something that we have built, or at least are still building in Nexla. It's called Nova, and it's our AI co-pilot for data workflows, and it's built entirely on an agentic foundation. So before I get into what Nova is or how it works, I think it's very important to establish why we built it in the first place. Because honestly, that story tends to resonate the most when we talk to customers. And I think you guys will relate too. So let me start by setting some context for this. One of the biggest initiatives inside organizations today, and I think that's across every industry, is the integration modernization piece. And that's because over the last few years, there's been a pretty dramatic shift in how enterprise stacks are built. So earlier, I think everything used to revolve around this giant monolithic ERP system, right? So think of platforms like SAP or Oracle Fusion. These were the systems of record, and literally everything ran through them and revolved around them. But now what we're seeing is that enterprises are moving towards what we call composable ERP systems, where instead of this one giant platform, you've got the best of breed tools for each domain. So you can think of Salesforce for CRM, probably Workday for human capital management, ServiceNow for IT service management, and so on. You can name a bunch of these tools. That's great from a business agility perspective, right? But think about the data. What happens to the data now? It's scattered. It lives in APIs, CSVs, PDFs, and all of these other formats, and it's all over the place. So if you think about it, the data which used to be the centralized asset now kind of has this fragmented liability aspect to it. So it enterprises today now need a modern way to connect all of these pieces and bring structure to the chaos. So of course, there are a bunch of tools in the market that promise to solve this in a low code, no code fashion, uh, do some visual programming in the format of drag and drop interfaces that promise you that, hey, you can build pipelines in minutes with us. And sure, that has gone a long way, but let's be honest about this. Every platform has its own quirks and it works differently. So if you think about Nexla, visual programming in Nexla is probably not the same as any other tool in that data integration space. So you're learning new systems all over again. And that's kind of like the irony also. The promise is that there is going to be speed and faster time to market. But in reality, that speed still depends on how you, as the customer, is going to learn the intricacies of the platform, right? So with that idea in mind, what we need today is not another probably a visual tool. We need a tool that can learn from us, that can understand what we are trying to do and help us get there faster, essentially. I think this is exactly the space where generative AI starts to make a lot of sense to us. This is also the place where I like to bring in bring in a quote from Ravi, who leads our solutions engineering at Nexla. And I think he puts it really well. So any AI success actually depends on the data and the context. Without both, your AI solution is essentially hallucinatory in nature. And that's exactly it. So we've seen a lot of generative AI pilots sound very cool on paper, and less than about, say, 4% of them actually make it to production. So what is the reason behind that? It's because these AI solutions don't essentially have a grounding in the actual data. And when you put it to production, it needs to be transparent about how it reasons or decides about a certain transformation or a solution that it develops. That's why we built Nova. It is not another AI assistant, but something that is more grounded in its production data, and it's designed to build with you and not for you, essentially. Okay, so let me explain what Nova actually is, right? Nova is a conversational AI assistant, to set the expectation right, that helps you build transform and orchestrate all of these data pipelines just by talking to it or conversing with it naturally. So the difference here is it's not guessing anymore. It's grounded in what we call the Nexla's metadata intelligence layer, which means it knows everything about your schema, it knows your field types, your sample data, and any operational metadata that we've accumulated upon connectivity. So think of it more like a co-pilot that helps about what's happening under the hood. It helps you iterate faster, and it helps people across domains, whether you are a non-technical business user or whether you are a technical user. Both of these groups are can move more confidently. So with this, if you want to code, you can. And if you want to talk to it, you can just approve the logic and the transformations Nova suggests to you. And that route is also covered. So we try to keep it explainable and flexible and meant for creating like real world workflows. Okay, so now that we know what Nova is, let's talk about how it essentially avoids certain LLM pitfalls, right? Like I said, at the heart of it is what we call the metadata intelligence layer. So you have this rich connectivity layer in Nova, and once you connect to any of these sources, what Nexla does is not just pulling in rows. We are capturing information about the field types, the sample values, the patterns across records, the relationships multiple fields have with each other. And this whole picture essentially just forms a metadata graph, essentially. And Nova uses exactly that to reason about your data. So think of an example. Say you want to say something like convert currencies to USD, or say clean up all data fields in the data set, right? So when you say these things, Nova knows exactly which fields to touch, what logic to apply, and how that fits into your broader data model. So this grounding is very necessary and is essentially what reduces the hallucination. Now, I won't say that this is completely error-proof or something, but the amount of hallucination that can come from AI solutions has gone down drastically because of this grounding essentially. Moving forward, for more technical users that want control, we provide the data-aware coding support on the platform as well. So I get a lot of people that ask, hey, is it actually using or generating any usable code? And the answer is yes. You can. The Nova knows the platform quirks and can output platform compliant code in the form of Flink SQL, which can be used for any aggregation queries, Python for any row level transforms, JavaScript, and within that coding platform, coding tool, you can invoke external APIs as part of your transformation logic. So you, for example, can connect to any external source for enriching your data set with any of the formats or like anything. So here's the best part, right? You're not locked into a code only or a visual only experience here. You can edit the code directly if you are a technical user, or use it on our visual UI itself, and just keep chatting with Nova and let it update things for you. Now, let's talk about something that's important to enterprises. So almost every large company has a canonical data model. It's the standardized structure that lets all of your downstream applications, like your analytics, your reportings, and compliance, all of these things depend on that canonical data model, right? So the problem is for these enterprises, incoming data never arrives very cleanly and is probably not mapped to that model. So think of DoorDashes or Geico's of the world, where you have multiple vendors and partners that are sending you in data that does not directly map to the model that you expect to receive it in. So you have partner feeds with different column names, files with random field names, any documents or PDFs, or any unstructured emails that are coming into you. And someone, usually like an analyst or an engineer on your team, has to spend hours mapping that data manually. this is again where Nova really proves its value. So because it knows both the canonical data model and what that incoming format is, it acts as kind of an intelligent translator. So it'll help you map these messy inputs into a structured, ready output that you can use for your downstream applications. And we've seen that this drastically has reduced the time it takes to onboard new data sources, right? Especially when you're working with multiple partners. So moving forward, structured extraction and text for text and image. This is probably one of the favorite parts of one of my favorite parts of what Nova can do, which is structured extraction. So the reality is not all data that comes in is in the format of, say, neat rows and columns. A lot of critical information lives in free-form emails or any scanned documents or any manually uploaded forms. All of that are unstructured pieces of data that also need this structured schema mapping, right? In a format that you understand, the canonical data model that we just discussed. This is again where Nova steps in. So for any image-based inputs, like a scanned invoice or something, we are able to extract structure out of it using models under the hood. So for this image example that I just shared, we use the Pixel model from the Mistral OCR package, which has which is the multimodal model that combines OCR and visual understanding. And for text inputs, we are using a GPT-4o model, which has like a tailored prompt and an output schema that it can conform to during, which can guide the extraction. So again, in this process, it's not just about, hey, look, that we pulled some fields. The goal is getting you some usable data that can fit into the rest of your pipeline. And we've seen success with this across partners in serving in the healthcare domain, the insurance domain, logistics, and any domain essentially that has unstructured or semi-structured data that is just floating around. So moving forward, I hope everybody's following so far, and I'm not losing you guys. But yeah, I think one cool thing about the platform that we have come up with is the concept of the private data marketplace today, right? It makes our plan is to make these data workflows accessible to more people, all by just having a conversation with the system. And we also want to ensure that the IT teams of these enterprises still stay in control. They can see what's being built, validate it, and they can make sure that the governance is in place for all of these data products. So this is how they can accelerate to let the non-technical users of the data use this in a more self-serve manner. So that's why Nexla has come up with the private data marketplace concept, where trusted assets are curated by core teams and made safely available to the rest of the enterprise. So it's a balance of autonomy and oversight that makes Nova really work in these enterprise settings, if you think about it. Now, let's talk about the real world wins. What does it actually look in the wild, right? So Nexla, I think in the course of last 3 years, has built 25,000 plus pipelines that run in production. And here's where it gets exciting. Since Nova officially got launched in the last 2 months, we've seen a 10% increase in the total pipeline creation. And to put things into perspective, over 3,000 pipelines got created using Nova. So we have seen the time it took for partner onboarding drop from weeks and months to days and hours now. So, and it feels that across the board, the time to insight has gotten much faster because the back and forth that was there between the business and the data teams now has been replaced with something much more conversational and collaborative. And yeah, so this just highlights that we're not just talking about a cool AI feature, but something that's used in the enterprise and shipping continuously. Okay, I think that's enough context about what Nova is and how it's built and what real world wins we could get with it. let's talk about something that I think will excite the community out here. Let's take a quick peek under the hood about this agentic workflow that powers Nova behind the scenes when a user kicks off a transformation request. So, okay, think of the user request coming in, and this first agent that it goes into is the initializer agent. So this agent takes in the user's prompt and the surrounding metadata context that we have accumulated in the beginning. And this sets up everything for the rest of the agents in the roster to take care of the transformation request, essentially. So from the initializer agent, it goes into a planner agent that is tasked with breaking down the user's intent into smaller tasks and action items. Or think of these as logical steps. And at this step, it's trying to figure out, hey, okay, this is the input user query. So what exactly needs to happen here so that I can serve the user request? So post this planning step, we hand off each of these action items to the query interpreter. And this agent is responsible for reading those steps and action items and deciding what type of transformation we are dealing with, essentially. So depending on the logic, essentially this agent then routes to a Flink SQL agent or a Python agent. And a Flink SQL agent would be helpful in the context of doing any aggregation queries or time window logic. And a Python agent would be necessary for any sort of row-level transformations, conversions, or parsing that you can do for that action item. So once the code is generated by one of these agents, we then move it to the evaluator phase. So the evaluator is what checks that the code is platform compliant or not. Is it dedicated to solve that specific action item? Is it doing that well or not? So once the evaluator gives the check mark, hey, saying that, okay, this transformation logic looks good, it's paired with the API agent to execute tool calls. So everybody in the community that has used Origin understands, AG2 understands that in a group chat setting, for executing tool calls, your agents need to work in a duo fashion. They need to work in pairs. So one is a tool caller, while the other is the actual executor. So that duo is the evaluator and the API agent itself. Evaluator makes tool calls for creating data products and any setup that goes after it in terms of sending any description about the transformation that took place and the result of which is this data product. So this setup essentially gives us modularity and visibility, and it also aids in the explainability of the system, and it still tries to retain that conversational experience to it. Moving forward, I think this is one of the most important things that we also slipped in this architecture, is to give the real-time updates with server-sent events. So this whole thing feels more interactive because of this construct. So server-sent events lets us stream updates back to the user in real time. So as each agent completes its task, its messages are sent to the front end so that the user is kept in the loop of what exactly is happening under the hood, right? This feedback loop is super helpful for two reasons, I would say. First is for user confidence. For the user now can follow what exactly the system is doing and thinking about when it's trying to solve a server user query. And second, for longer running tasks, it helps people feel like the system is not just frozen or idle. And it's a very small feature, but it goes a long way from an optics point of view in terms of building the trust with the user. So now we can see the full architecture diagram visually of what it happens. Of all the text that I gave you before, this is how it maps visually. So you have a user request that comes in. Then we have a metadata layer that plugs in early. So we have schema level understanding of the data that we are dealing with. Then we go through the steps of the initializer, the planner, the query interpreter, and we have server-sent events to send all of this information, stream all of this information back to the front end for visibility. And the query interpreter kicks off each of the action items on the plan given by the planner agent. And it assigns one of the two agents, data transformer or the Flink transformer agent, to take care of them in a Python or a SQL fashion. And the evaluator understanding and evaluating all of that logic, and co-programming with the API agent to execute tool calls that are necessary for completing that or checking off that box on the plan. So at the end of this, when it goes iteratively back and forth through all of these agents to finish off the entire plan, the summary of all of these transformations is essentially streamed back to the front end and is an explanation of what all transformations were carried out to serve the user request. So this architecture that you see is the backbone of how Nova builds data pipelines. Hopefully everybody is following so far. And we can take any questions at the end of this. But moving forward, we have structured extraction workflow. So yeah, this is a slightly different flow, and it is actually optimized for unstructured sort of inputs. Now, how it works, right? So when the user query flows in, even before it reaches a roster of agents, we are doing a step for intent classification, where we find, based on the data source, whether this needs to be routed to an unstructured to structured sort of extraction workflow, or if if the data source is a structured one, then we do go into the workflow that I just shared with you about the architecture. So once it's recognized that the data flow is one that requires structured extraction, we kick it off to a different roster of agents. Here, the first agent that comes into play is the input analyzer, which inspects your request. It figures out from the data source whether it is a text or an image input. Is there a schema template or a canonical data model that we need to conform to? And what the expected output structure should look like once this structured extraction is done. So once that part is clear, we set it up for the code agent, which generates the actual transformation logic. Now, this transformation logic is not exactly where the structured extraction is happening. What it actually is doing is making an API call to our GenAI server itself, which has this structured extraction endpoint and where all that heavy lifting is happening. So these agents are essentially just creating a data product which in its transformation code is essentially making an external API call to our own GenAI server, which does the structured extraction of the input. So the struct code agent creates a transform code. The struct caller agent is what figures out how to set up this new data product, which co-programs with the struct executor agent, and they execute these tool calls in a duo mode. So this flow is pretty simple, but I think it's quite powerful, and it can let you go from any scanned document or any messy input all the way to a clean JSON object mapped to a schema that you care about. Yeah. So this is the structured extraction flow. To understand it visually, you can think of a query that comes in like, say, tell me about, say, pull an invoice number, date, or say a vendor name from this input PDF, right? So the input gets to work there. It understands using the schema and the metadata and understands what's required from this user query to how to serve it. The code agent writes the right transformation logic. The caller agent is what packages everything up, creates a new data product in coordination with the struct executor agent. And that new data product is what makes an API call to our GenAI backend, where this structured extraction heavy lifting happens. Okay, so yeah, what are the key takeaways, right? Let's probably zoom out for a second and talk about what Nova really brings to the table. So essentially our dream is to make all these data workflows, and we've put in the effort to make that a reality today, where you can create pipelines and data workflows conversationally. using natural language. And we want to emphasize that structured extraction isn't just like a side feature. It's becoming a gateway to a whole new class of AI native automations. And we are seeing that open up real value when it comes to customer meetings and stuff. So the third is the agentic design that gives us the explainability and control for all of these agents. Each agent has a purpose here, and users can see how the system essentially thinks when it takes on a request and is solving it. So you are in the loop in that entire process. And lastly, everything this solution does is grounded in metadata. And that, I think, is the real differentiator. Because this context-aware AI that knows the schema, your goals, and rules is at least not going to be, the hallucinatory nature aspect of that is drastically reduced. So just to set the expectations right? So this isn't here to replace your data engineers. I think we know better than that to sell that dream. Nova here is a co-pilot, of course, and is not a magic button. It won't build your data pipelines autonomously. What it does help you do is it will help you iterate faster and understand these transformations more clearly, and maybe even onboard on your team users that have probably never even touched code before. So that's what we're trying to enable here. Okay. Yeah, all this has been cool. So let's do some AG2 reflections, right? That's what we're here for. Building on AG2 has been honestly really fun. So the framework is, of course, very flexible. It is quite developer friendly. And I think it maps perfectly to how we think about real world data orchestration problems, right? And I think the best part about it is also the community. I think you guys are awesome. You guys are super active and super helpful. And there's a lot of energy here, which makes it quite refreshing. Yeah, I think moving forward, this thing becomes really cool when we have support for MCP. And I'm quite sure that is probably in the works with the AG2 community here too, because that is going to make tool integration and agent chaining and all these things much more powerful and like reusable across workflows. It's clear that AG2 is definitely becoming like a backbone of our own agentic automation, and we are only just getting started. So yeah, it's been quite fun using the AG2 framework. Now, with all the good things that we've said, I think I would do a disservice to this community talk if I did not share with you some challenges that we hit or the few speed bumps that we hit, right? So one takeaway from this is that one thing that we're looking into closely right now is improving the performance of the system. And one way we were thinking about solving that problem is by using caching. So caching with Redis today, I think in AG2 does not support the SSL mode. And right now that has been a sort of a blocker in our setup, but not a big one because we are doing away with it using the non-SSL setup itself for Redis cache. And the second one, I'm not sure if this is still an issue, and I don't want the AG2 community to be hating on me, but the PyAutogen version that we were on is restricted to OpenAI LLM configs only when it comes for tool calling. And that support probably would be great if it could be extended to, say, other model providers like Claude or, say, DeepSeek or any other things. So that way, moving forward, we can enable multi-provider agent setups. And that would be a cool thing in terms of flexibility. So these are all obviously very solvable, and I'm optimistic, especially with how responsive this AG2 team and the community has been. So what's next, right? If anything I shared here with you resonated with you, whether you're building your own agent stack or trying to onboard non-technical users, or just curious about what's working, I would love to chat with you guys. And of course, if you're using AG2 in a novel way, I'd love to hear from you too. So yeah, that's pretty much it from my side for this presentation. Thanks again to the team here for having me and to all of you for tuning in. I'll open it up now, and I'm happy to take any questions you have or dive deeper into anything you'd like. Thanks.
So the question is because is someone moderator.
It may have some problems with your phone.
Yeah, sorry, I couldn't hear that question very clearly. Could
Yeah,
you repeat that?
I also cannot hear that. Maybe you could directly put your questions in the chat channel. Hi, Jane.
Yes, left a question in chat.
Yeah.
Okay.
So I see questions in the chat now. Probably I can take some up that came during the presentation. So the first question from Chi is, for what task did Nova reduce from 6 weeks to 2 days? So yeah, that's a great question. Like I said, the partner onboarding part of the challenge was something that we were able to were doing only in the time frame of weeks and months. And now, because you can map to all of these sort of messy inputs that we are getting and do transformations to expected canonical models with Nova, you're able to bring that value to customers, where you can now say that, hey, get a new vendor, get that data product connected to that source, and now we can map that data source to your canonical data model in the matter of hours. It doesn't even take that much time, but to obviously to GA it takes a couple days. Yeah. So the next question is, did the planner always generate the right plan? Did the executor always follow the plan in Nova? Okay, great question. So yeah, like I said, the metadata intelligence layer is what's embedded into the roster of these agents, right? So the planner has visibility into the schema, the samples, and everything, and it creates a step-by-step plan for how things need to be taken care of. So sometimes when I'm saying that, in the Nexla sphere of things, when you're executing everything step by step, you're creating data products for each of these action items. And the planner does not always come up with the most optimized plan. So we've given the flexibility to the query interpreter agent to interpret these action items and combine them whenever it's necessary, so that we are not creating more and more data products in the pipeline unnecessarily, and we are able to optimize that action plan and combine and like condense them into simpler steps. So that planning step is just to set the context right for the roster of agents, but we still give the flexibility for the query interpreter to condense that into simpler forming logics. Hope that answers your question. Yeah, do you have security concerns executing generated code in production? Executing generated code in production. Yeah, so security concerns are essentially in the format of any customer wondering if the data is flowing to the LLM. But I think that's an upfront contract that we have with them, that we collect a few samples of your data and your data doesn't lie within the product, essentially. It is only to make the LLM more aware about what sort of transformations have to be in the place. Once that transformation logic is set up in the platform's execution engine is what takes care of that generated code. So in production, I would say there are no like security concerns. We are giving ample governance and visibility into what is happening under the hood. Yeah. Going forward, how did you guys manage to handle transitive table joins and then efficient query planning? Any relational algebra concepts or just pushing it down to BigQuery? So yeah, that is actually a great question. So that is actually a platform limitation today, where multiple data workflows or data flows can't interact with each other because we don't have the concept of table joins across multiple of these data products. So essentially, when you're connected to a data source, we are only able to talk to that data source and create any transformations according on that. So that is definitely an item that's on the roadmap for the platform, and we are looking into how that can be best served. Yeah, and let me know, guys, if you have any other questions that still need clarifications. But yeah.
Jan asking another question. What type of enterprise design pattern did you use to translate the agentic infrastructure to SOA microservice-based system?
Could you elaborate on that question a little bit? I don't probably fully get it.
Okay.
Enterprise design pattern. How did I distribute the agents? So these agents are essentially working in a group chat fashion, right? So when you get input questions, these agents have context about what is all the information there to work over distributed multi-tenant architecture. Yeah, so the multi-tenant architecture here is essentially just the fact that your connected source, which probably could be BigQuery or Postgres or any other file upload, this information is flowing into the roster of agents, which have information about the entire context of that input query. And now the agents are working in a group chat fashion where they have context about what every other agent is responsible for and is doing when they're kicking off an action plan. Yeah, so that group chat fashion is what the distributed agents look like, essentially. If I'm getting your question, understanding your question correctly, that is. So the agents are essentially stateless actors, no message brokers, distributed queuing, message bus. So yeah, the servers and events that I told you about is essentially the buffer that sits within between the main application and the agents. So that's a very important question that you asked. So essentially, what we are doing is when we are streaming all of these outputs from the agents to the front end, what we are doing is we are decoupling the agent workflow from the main server code. So this async queue that's sitting in the middle of these is actually honestly is listening to any of the outputs that are thrown by the agents. So if you've used the agent architecture, all of these agents are always printing to the standard output. Literally, like on the terminal, you can see these outputs. And at that print function is essentially what is like monkey patched by us right now. And whenever an agent is like printing to the terminal, it's also putting a message on that shared queue. And the server that is listening on that queue updates using servers and events, sends that message to the front end. So edge cases, I think it was initially big, with the plumbing effort that went into it, because this has to be run in a separate thread. And I think we try to like leverage async IO to run this thing, and we ran into like issues of this not conforming to the main event loop and stuff like that. So the threading part is what like really took care of it. And it's pretty straightforward once you've broken down the problem like that. Yeah. Hopefully that answers all of your questions, guys.
Any
This is
more?
awesome. Yeah, let me know if there are any more.
Is there any more questions here? Okay, it seems it has no questions from the audience. Okay, that's all. Thank you, Noah, for the incredible presentations, and thank you everyone for joining today's sessions. And I will also share the slides and the recording with the community later. And Noah is also in our communities. Feel free to reach out if you have questions regarding Noah and other things. Yeah.
Yes. Awesome. Thanks, guys,
Awesome.
for tuning in. Have a great day ahead.
Thank you, everyone. Thank you. Bye.